Hello guys, welcome to Small Somewhere Maths tutorial. So the today's lesson will be solving a homogeneous second linear equations. So we are going to follow all the steps which I wrote here to solve example 1, 2, 3. So in simpler terms, let's just explain this the steps before we can attempt to solve those questions. So you'll be given the differential equations which here is represented by what? By dE, which is a to the second prime plus b to the first prime plus c1. Remember the second prime is also the same as the second derivative. So whenever you see d squared y all over dx squared, don't get confused, it's the same as the second prime, right? So you'll be given the differential equations. It can be in terms of y. So whenever it's in terms of y, you are going to write the first step when that you're going to write is what is your auxiliary equation, which is represented by what? By ae. As you can see that our a is what? It's am squared plus bm plus c. So if you can check the differential equation and the auxiliary equation, we replaced the second derivative with what? With m squared. And we also replaced the first derivative with what? With m. And for cy, we just only wrote c. We just took the coefficient of y, right? So this is what the auxiliary equation is all about. You'll see how are we going to use these formulas. So in simpler terms, we're going to replace the second derivative and the first derivative with what? With the m values. With the m, not the m values, with m. So after we'll be having what? We can see that we'll be having a quadratic um equation. So we need to solve for the y, the m values. So how are we going to solve for the m values? You can use a quadratic formula, because here you can see that we wrote the quadratic formula. You can use a quadratic formula, or you can just factorize. If it's simple for you to factorize, use the factorize method. If you find it difficult to find the factors, then you can use the quadratic formula. So after using the quadratic formula, we have case 1, case 2, case 3. Uh, from case 1, let's explain case 1. From case 1, if you find that if you calculate b squared minus 4ac and you get the value which is greater than 0, this is the formula that you're going to use, which is y is equals to c1 multiplied by e to the power of m1 multiplied by x plus c2 multiplied by e to the power of m2 multiplied by x. So this formula, we are going to use it whenever our b squared minus 4ac is greater than 0, whereby we'll be having the distinct real roots of m1 and m2. This is our case 1. So for case 2, so how do we use case 2? We are going to use the formula of case 2 whenever our b squared minus 4ac is equals to 0. Therefore, we are going to use this formula which says y is equals to c1 multiplied by e to the power of mx plus c2 multiplied by x multiplied by e to the power of mx. So whenever we have repeated roots, so let's say you are given the you have calculated your m values and then you found that your m values are the same or are equal. Therefore, this is the formula that you're going to use, which is the case 2. So for case 3, if you calculate b squared minus 4ac and your value is negative or is less than 0, right? This is the formula that you're going to use, which is y is equals to a to the power of alpha multiplied by x into c1 multiplied by cosine of beta x plus c2 multiplied by sine of beta x, right? So meaning Whenever you have complex roots, this is the formula that you're going to use. Remember, we get the complex roots whenever we have like the square root of a negative number. That's where we get the complex roots. So let's do the example while using the steps which we wrote here. You can see what we are talking about. So the first example, we can see that we are given y to the second prime plus y to the first prime minus 6y, which is equals to 0, right? So is the first step from, we can see that is what is the differential equation, which is a multiplied by y to the second prime plus b to the second prime. So what we did, we wrote what from the second step, you need to write what your auxiliary equation, right? We talked about the auxiliary equation. We said from the auxiliary, okay, let me write opposite. We said from the auxiliary equation, we replace the second derivative and the first derivative with what? With a, right? But then we leave our coefficient the way they are. We can see that the coefficient of this example here is what? It's 1, right? So we're going to replace the second or the second prime with what? With m squared plus the first prime. We're going to replace it with what? With m, right? Minus, we have 6y, and if we can check from the example, we had 6y, and then from the auxiliary equation we only wrote the coefficient of c. So even here we're going to write only the coefficient of y, I mean. So meaning here we're also going to take only the coefficient of y, which is what? Which is negative 6, therefore is equals to 0. Then we wrote our auxiliary equation. After writing our auxiliary equation, we need to find the values of m. Like I said, you can use the quadratic equation or the quadratic formula, or you can just factorize. So this one, it's simple to factorize it. We can factorize it, whereby we're going to have m here. Also give to have m, because we have negative, it's going to be positive and negative, and then we are going to have 3 and 2 here. Therefore the values of m is going to be negative 3, or m is equals to 2, right? Or remember, it's something like this, guys. Yeah. Then the values of m is negative 3 or m is equals to 2. So now we come to what? To case 1, case 2, case 3. How do you know that which formula are you going to use? That's where we come, we are going to write b squared minus 4ac, right? After writing this formula, we are going to find the values of b squared minus 4ac. We see it gives us how much. So for b, we see that it's 1 squared minus 4 into 4a is 1, 4c is negative 6, right? Which the answer is going to give us 25. So as it gave us b squared minus 4ac, as it gave us 25. So meaning now we know that our b squared minus 4ac is greater than what? It's greater than 0, because you can see that it gave us what? 25. Meaning is that you are going to use what? Case 1, right? So what is the formula of case 1? We can see that the formula of case 1 is y is equals to c1 multiplied by e to the power of m1 x plus c2 multiplied by e to the power of m2 x, right? So therefore, now the only thing that we are going to do, we're going to replace m1 with the values that we get for m1. You can name this one 1 m1, then you can name this one 2, right? So therefore we're going to just replace it. Therefore we have c1 multiplied by e. What is m1? You can see that m1 is negative 3x plus c2, which is e, and then our m2 is what? Is 2x. Then we are done solving this equation of homogeneous second linear equation. This is how we solve it. You saw that, guys. After finding these values of m, we do what? We write b squared minus 4ac and we check which value we got. If the value it was negative, obviously it's fall under what? Case 3, right? So you'll see, let's do case 2 now. I'm going to erase here so that we can do case 2. Okay, so now we do example 2. So example 2 is given as 4d squared y all over dx squared plus 12 dy all over dx plus 9y, which is equals to 0. Right, so solve the equation. So the first step, we know that we are given what? The differential equation. We need to write it in terms of what? As the auxiliary equation, so that our values can be in terms of what? Of m, right? So therefore we write what? Auxiliary equation. So we are going to write 4, and then for d2 y over dx squared is a what? Is the second derivative what? Right? So we're going to write m, because it's the second derivative, we need to include what? 2 here. Therefore plus, then we write 12. Therefore dy over dx is the first derivative, mean we're only going to write m, right? Plus 9y, we only take, like we said, we only take the coefficient of y, which is 9, therefore is equals to 0. This is the our auxiliary equation. After writing the auxiliary equation, we said we do what? We are going to find the m value. So you can either use the quadratic equation or the quadratic formula, or what you can just factorize, right? So I prefer to use the quadratic formula here. So it's going to be m is equals to mb plus or minus into b squared all over 4ac all over 2a, right? So we know that for b we have what? It's 12, therefore it's 12 plus or minus into the square root of what is b. You can see that our b is 12 squared minus 4 into our a is 4, then our c is what? It's 9, therefore all over 2 into what is our a? Our a is 4, right? So the final answer is going to give us, okay, the final answer is going to give us minus 1 plus or minus, wait guys, not minus 1, made a mistake. Okay, we can see that we have negative 2 plus or minus to the square root of 0 all over 8, right? So therefore our m1 is going to give us negative 3 all over 2, or m2 is going to give us negative 3 all over 2, right? So if you went through all those three cases, for case 2, you can see that now we have case 2, right? Whereby m1 is equals to m2. Can you guys see it? So, but then if you're not sure about it, you can also use that formula, which is b squared minus 4ac, right? So therefore we need to calculate, and we can see that b squared minus 4ac is equals to what? 0. B squared minus 4ac is equals to 0. This is what we wrote here after calculating b squared minus 4ac. We found that our answer is 0. So this thing is tell us that, okay, meaning we need to use what? The case 2 formula. What is the case 2 formula? You can see that the case 2 formula is y is equals to c1 e to the power of minus multiplied by x plus c2 x e to the power of mx, right? This is the formula for case 2. Whenever you have repeated roots, whenever we're talking about the repeated roots, meaning the two values are what are equal. So m1 and m2, we can see that they are both what equal. And whenever b squared minus 4ac is equals to what 0, so it's either you're going to check whether m1 and m2 are equal, or you can use that b squared minus 4ac is equals to 0. If it's equals to 0, therefore you are allowed to use what? The case 2. Right, so now let's replace everything. Therefore we have c1 e. What is m? We can see that m is represented by what? Minus 3 all over 2 plus c2 x e. M is what? Minus 3 all over 2 what? X, right? Forgot to put x here, and also x here. Therefore this is how we do how we solve the homogeneous second linear equation. So you can see that, guys, if you have this these steps here which I wrote here, you have everything that you need. We saw that, okay, for case 1 we saw that b squared minus 4ac it was greater than 0. That's why we used this formula, right? And now we can see that from case 2 m1 is equals to m2, so therefore we are allowed to use the formula of case 2. And we also prove that b squared minus 4ac is equals to 0. Therefore we can use this formula. So you'll choose which one do you prefer, whether m1 is equals to m2. After proving that they are equal, you can use this one. Or after proving that b squared minus 4ac is equals to 0, you can use what? Case 2. It will depend on you which one do you guys prefer, but they are both equal. Right, so now we're going to do the example 3. I'm just going to erase here. Okay guys, so let's now do example 3. We're given the second prime minus 6 first prime plus 13y. Oh, this is what we already know, that this is the differential equations. We need to change it to what? To the auxiliary equation, right? So from the auxiliary equation we only change the second derivative, but we leave the coefficients the way they are. So from here we know that we have because the second prime or the second derivative is going to be m squared minus 6m plus 13, right, which is equals to 0. Therefore after we do what? We find the values of m. We're going to use what? The quadratic formula. So guys, it's very important to use the quadratic formula. The reason is you're going to see whether your your equation it's it's real or non-real, right? So from this formula we know that from negative b we're going to have into negative 6 then b squared. So I'm just going to write the answer of it. So you're going to get 6 plus or minus the square root of negative 16 all over 2. And if you can press this thing on your calculator, it's going to be it's going to say math error or what ne? Because of the negative root. So how do we solve this? We are going to say 6 plus or minus 1 multiplied by the square root of 16 all over 2. Remember that the square root of negative 1 multiplied by the square root of 16 is the same as the square root of negative 16, right? So after this, if you don't know about the complex numbers, we know that I is equals to negative 1, right? This is what you need to know. We know that I is equals to negative 1. So where we see negative 1, we are going to replace it with what? With I. So we're going to have 6 plus or minus the square root of 16, which is 4, multiplied by I, which is negative square root of 1. Do you guys see it? Which is all over 2, right? So after we're going to find that our m1 is equals to 3 plus 2i, or m2 is equals to 3 minus 2i, right? So now after finding the values of m, we know that we come to what? To the cases whereby we are going to choose what? The equation. So from here guys, it's obviously that we had um the complex roots, right? We have the complex roots. How do we see the complex roots? We can see that we have I, and when we calculated 6 plus to the square root of negative 16 all over 2, it gave us our math error because of we have the negative root. So this is how we do it, whereby we know that I is equals to negative 1, right? So we need, whenever you have negative, okay, let me just explain it a little bit. Whenever you have a negative root, like for instance here we have the square root of negative 16, right? So to write it in terms of the complex numbers, what we are going to do, we are going to say negative 1, which is here, the square root of negative 1 multiplied by the square root of 16 is the same as the square root of negative 16, right? So meaning we need to take the negative 1, the square root of negative 1, so that we can replace it with what? With r. I hope it's clear now. So therefore, after we found our m1 and m2, right? So we can see that these values are the what? Are the complex roots. Even though you're not sure about it, we said we can use this one, which is b squared minus 4ac, right? Therefore, b squared minus 4ac here, we found that the answer is what? Is negative 60. And we said that whenever b squared minus 4ac is less than 0, therefore we're going to use what? Case 3. So also here we're going to use what? Case 3, because we have the complex roots. So for case 3, it's y is equals to E alpha multiplied by x into C1 cosine of beta x cosine of beta x plus C2 the sine of beta x, right? So now we are going to replace our values. So how do we replace our values? Okay guys, let me write it here, let me explain it here because we don't have space. Remember we said from the case 3 we have alpha plus or minus beta, right? So meaning if our values is 2 plus or minus 4i, right? So we can see that m is equals to alpha plus or minus beta I. So meaning this 2 is what? It's alpha. And then this 4 here is what? It's beta. Okay, I know that there'll be those ones who say, but say we have positive and negative. Okay, guys, from this one, we only focus on the coefficient of I, right? Which is what? It's 4. We forget about the negative sign. We only take 4 the way it is. So meaning for here, alpha is equals to what? Is equals to 2. And then beta is equals to what? Is equals to 4. We don't care about this negative. We just take it the way it is. So let's now replace these values. We have E. What is our alpha here? We can see that our alpha is what? It's 3. It's going to be 3x into C1, the cosine of what is our beta? Our beta, we know that is the coefficient of I, and then we said we only take what? The number. We don't care about the sign, so it's going to be what? 2x plus C2 sine of 2x. Therefore, that's it. That's how we solve this example. So we did case 1, case 2, case 3. That's like is everything that you need to know from solving the homogeneous second linear equation. If you know case 1, case 2, case 3, therefore you are done with solving a homogeneous second linear equations. You'll never go wrong if you know this case, which is case 1, case 2, case 3. So from the second video, we'll be talking about the initial value and the boundary values, right? So kindly subscribe and like and leave a comment if there's something you didn't understand. Anyways, thank you. Yeah.